Hello, welcome back. In this video, we will talk about techniques involved in decoupling the data. Let's consider a scenario. We have an order service, we have a customer service. The order service is responsible for catering to orders made by a customer and it has details related to the order. The customer service has information specific to the customer, and one of the information of interest is the credit limit. How would we put this data? Which database architecture will we use? The simplest approach which we can think of is create two tables, one for the order service, one for the customer service, and put it in a single database. Now, both the order service data and customer service data exist in the same database and is accessible for both the services. Good. What does this give us? A single database for multiple services. It's a straightforward asset transaction. The database guarantees atomicity, consistency, integrity, and durability. However, there's a disadvantage. We have now tightly coupled both the services. This also introduces a single point of failure. This approach will not scale well when you have to scale the services. A single database will become a bottleneck. A single database may not be able to store the different type of data each service may need. So what is the alternate? An alternate approach is to think each service using its own database for its data. In this particular example, order service has its own database where it has tables related to the order. The customer service has its own database where it has tables related to the customer. So each service has its own database. The data is now private. This allows us to use different tables and different schema in each of the database according to the service we want. This also allows us to scale the database as the service needs. A customer service may not scale as big as the order service. So that's very dynamic and the database will cater to that. This also conforms to the decentralized data management principle of a microservice architecture, where each service manages its own data. However, how would you handle a transaction that needs synchronization between the two services? Let's take an example. The order service needs to ensure that the credit limit is not exceeded before placing an order. The credit limit is not known to the order service. The credit limit exists in the data of the customer service. So how would we make sure both these data are synchronized and the transaction happens without affecting the flow? The answer is Saga. Saga is a sequence of local transactions. As depicted in the diagram, you would see if there are multiple services, one service would do a local transaction and then raise an event. The second service will act on the event and make its own local transaction. And it may raise another event which a third service may wait for and do its local transaction. So it is a sequence of local transactions moving from one service to another service. Let's see it in detail. So after the first local transaction happens, the service pushes a message or an event. This event triggers the next local transaction in the saga. If the local transaction fails, the saga executes a series of compensating transactions which will take the database, all the databases, back to the old state. This will undo the changes that were made by the preceding local transaction. So all services are eventually consistent. Now there are two mechanisms how saga can be achieved. Let's take our example of order service and customer service and see how it works. The first way how Saga can be done is called choreography. In choreography, we have again order service, customer service as depicted in the picture. Let's say a new order has to be created. The order service would create an order in its database and keep it in the pending state. As soon as the order is created, it emits an event called order created, which the customer service listens for. Once the customer service receives the event, it looks at its data and reserves the order amount so that from the credit limit. This ensures the credit limit is not crossed. If everything goes fine, the customer service emits a credit reserved event, and that is listened by the order service. On a successful credit received event, order service approves the order which was created before. In case of a failure where the credit limit has exceeded, the customer service would say credit declined. That event would then go and reject the order which was created. So, as you saw in this particular scenario of Saga, both the services knew exactly what to expect for. The order service emitted order created, the customer service was listening to it. The customer service emitted a passing event or a failing event which the order service knew. So this is called choreography. An alternate approach to this is what we call as orchestration. In this, the order service will still implement all the internal calls of creating the order, approving it, and rejecting it. And customer service will have an internal call to reserve the credit limit. However, the transaction between the order service and customer service does not happen in one to one, but there is an orchestrator. The order orchestrator will now define what happens first. So, in the case of our scenario, when a new order request comes, order orchestrator would tell the order service to create an order in a pending state. Then the order orchestrator would ask the customer service to reserve the credit limit. Depending upon the communication from the customer service, it will again ask the order service to either approve or reject. The benefit of orchestration is that the order service and the customer service do not know about each other. They only talk to the order orchestrator. To summarize, there are two ways where how Saga can be implemented. One is using choreography, where the services talk to each other in a direct way. This is often simple to understand, and this is useful when your transaction involves less number of steps. However, if there are too many dependencies, then this can become complicated, and that is where orchestration comes into picture. Orchestration facilitates centralized management of transaction. The complexity at the individual service level is reduced. The orchestrator takes care of handholding. It removes cyclic dependencies, and this also, since there's a level of abstraction at every service level, this eases testing effort. Every service can be tested in isolation, and orchestrator is the central piece which communicates across all the services. What did we learn in this session? We learned about different DB architecture, a shared database per service, and we also learned if we have to handle updates across DB, how would we do that? We learned about Saga, and we learned about two types of implementation of Saga. One is choreography, the other is orchestration. As always, keep thinking cloud. Get back to us if you need any